In this video presentation, we will discuss a descriptive statistics, which is a measure of variation. So the following are the measures of variation. So it is the range, the interquartile range, mean absolute deviation, variance, standard deviation, and the coefficient of variation. So let's start with the range, which is just the difference between the lowest and the highest observation. So if we have the set of data of randomly selected customers and their age, what is the range of the data set? So you just need to get the lowest value and the highest value. So in this case, the range is just 41 minus 19. That is equivalent to 22. Next, the interquartile range, or the IQR, is the difference between Q1 and Q3. Now, solving for Q1 and Q3 was already discussed in the measure of position presentation lecture. Using the same examples, find the IQR of the 5 randomly selected customers in their age. So, solving for Q1 and Q3, which we solved in the previous presentation, that is 22 for Q1 and 36.5 for Q3. So the IQR is equivalent to 14.5. Now, additionally, to get the lower bound of your dataset, that is equivalent to the first quartile minus 1.5 times the IQR. So that is 22, the first quartile, minus 1.5 times the IQR of 14.5. So the lower bound of your dataset is 0.25. Similarly, for the upper bound of your dataset, so that would be Q3 plus 1.5 of the IQR. So Q3 is 36.5 plus 1.5 times the IQR, which is 14.5. The upper bound is equivalent to 58.25. Now, listing down the values that we have, so that is the upper bound, the highest value, Q3, Q1. So the Q2 is the median of the dataset, which is 27, the lowest value, and the lower bound. You can actually construct a graph, which is the box plot, or the box and whisker plot. So the component, or the components of the box plot, are the following. Now, constructing the box and whisker plot for this data or data set, you can actually use Excel or other statistical tool to generate its box plot. Now, the upper bound and the lower bound of the data set actually tells us if the data set has an outlier or has outliers. So if the value goes beyond the upper bound and the lower bound, then those values are already considered as outliers. So if you're going to plot or create a box plot with outliers, this is what it looks like. So there are dots or points outside of the box plot and beyond the maximum and minimum part of your box plot. The next measure of variation is what we call the variance. So again, there are two types of variance. You have the population variance, denoted by sigma squared, which is computed as the summation of the square of the difference between the data minus the population mean all over the total number of observation n, and the sample variance denoted by s squared, which is actually similar to the formula for the population variance, except for the denominator now is the total observation minus 1. So in this example, taking in consideration that you have all 5 students where your data were collected, it means that you're solving for the population. So compute the variance for that data set. So the population mean is equivalent to 11 hours. And using the formula for the population variance, so you have to be careful regarding identifying if you're solving for a population variance or the sample variance, because notice that your denominator will change. So in this case, since this is a population variance, your denominator is equivalent to the total or all of the observations, which is equal to 5. So your population variance is equivalent to 8.4 hours squared. Next, in this example, you have to compute for the variance of the age of the randomly selected customers. So in this problem, since we're dealing with samples, you will use the formula for the sample variance. So computing for the mean of your data set, that will give you 28.8. And for the sample variance, notice that your denominator for the formula is n minus 1. So instead of using 5, your denominator now will be equal to 4. So the sample variance of the data set is 68.2 years squared. So take note that for your data set from x sub 1 up to x sub n are random samples from a population with variance sigma squared, then your sample variance s squared is an unbiased estimate of your population variance sigma squared. The next measure of variation is your standard deviation. So to get the standard deviation, you just simply get the square root of your variance. So for the population standard deviation, that is denoted by sigma, whereas the sample standard deviation is denoted by S. So in the previous example where we get the population variance, compute for the standard deviation. So just take the square root of your population variance, so square root of 8.4 hours squared, that is equivalent to 2.90 hours. So meaning the value or your data set varies 2.9 hours from each other. So next example, compute for the standard deviation of the 5 randomly selected customers and their age. So since we get the sample variance a while ago, so to get the sample standard deviation this time, you just need to take the square root of the sample variance, so that will give you 8.26 years. So meaning the age of the customers is 8.26 years away from the mean. Now take a look at this question. You have two data set A and data set B. Which variable has more variation? Now notice that the standard deviation for these two data sets are the same. So at first glance, it looks like it's hard to tell which one has more variation. But notice that obviously their means are not the same because the values in dataset B is more larger compared to the values in dataset A. Now, to answer this question, what we need to do is to compute for what we call the coefficient of variation, or that is the standard deviation divided by its mean. Now, solving for the coefficient of variation for these two data sets, we can see that the coefficient of variation for data A is 47.35%, whereas the coefficient of variation for data B is just 0.16%. So if you're going to interpret this result, it means that data A has more variation, or the data or observations in data A varies more compared to the data in data B. And it means that since data B or the dataset B has a smaller coefficient of variation, the dataset here or the dataset in data B is more consistent. So we use the coefficient of variation to compare the variability of two or more variables with different means, or two or more variables with different units of measurement.